Welcome to the next section about asynchronous communication protocols. In this section, we're going to see the server send events protocol and the WebSocket event. So first of all, we're going to see how we can implement server send event endpoints with JAX-RS and also access them with JAX-RS, and then how we can implement server WebSockets using the WebSocket API standard for both server endpoints and client endpoints. And the first video is about how to implement server send event resources with JAX-RS. We're going to see how we implement these server send event resources and how JAX-RS supports SSE. And then we're going to see how to use the types SSE, the broadcaster, and outbound SSE event with the content type that we need text event stream. So let's assume we have our car application again, and let's stream the output for created cars. So let's say we want to create a server send event stream. Therefore, we create a resource for it. For example, car created events resource. And this will be a JAX-RS resource. So JAX-RS supports SSE. And we call this car created events. And also, we will have to annotate it with singleton. We will examine later on why we need this. And then let's assume we will have a method where we get a stream for stream created cars. And this method, of course, will be annotated with get. So once we access this path, then we will get the stream. And now it's interesting since we have a new media type, which is this server send events media type that we need for the text event stream. And now we can inject with add context an SSE EventSink. And that sync is the sync on that specific client where we can then later on stream events to. And by doing so, we need a so-called broadcaster. And for that, we need two things. First of all, the SSE context that we can inject with add context. And then we create an SSE broadcaster. So what that is we say we want to have a new broadcaster that is then used for all the events that are part of this resource. So basically when several or multiple any clients connect to this resource, then we can broadcast to all of them once we stream new events. So this is the idea. And then what we need is we want to use the broadcaster to register that sync. And that's already it. And then later on, we can say we listen to our CDI event that we had in our application, for example, the car created event that we had similarly to before. And then we can take the broadcaster to broadcast a new event that we create based on the car created event. And that event is also created by this SSE context by saying, give us a new event for example, the car identifier. And then we already send it. And that's it for now for sending the events. What we could do also is if we control the last event ID, then we can resend events to clients that have been disconnected in the meantime where we send new events. So basically we can capture all the events and redistribute them for clients as another feature. For that we need first of all to extract the header param for the last event ID. So that means client can send the last event ID as a header, and then we can react to it. Per default, we want to set a default value that will be -1, so no last event ID. And that means we, of course, register this at first, and then if there is a last event ID, if it's greater equals 0, then let's say we want to resend the missing events for this particular event sync for, well, all the missing IDs from that ID on. And in order to do so, well, we first of all have to store all the events, of course. Therefore, we create a list of car created of our events. We call this created cars. And we still have a singleton, therefore we can do this. And also, then we can say we can iterate over them. For created cars size, please resend the particular event. Created cars, get I. And then, well, we need to do two things. Let's start here from the last event ID. First of all, we need to capture our specific event here. That means created cars at the car created event. And then also we need to send the ID. Otherwise, we just send the data in our event stream, but we also need to set the ID explicitly. That means we will say, please create an event here for, in this case, of course, I+1. And then in our case, we say created cars size +1 in this case as well. By doing so, we can say we want to have an event builder, and now we can use the ID, that event ID plus the data that we had before, car created, get identifier, and then we build this new event out of that. And we can do so because we can lock the methods here implicitly from the singleton lock. So that means in this case, we actually want to restrict that less and say this is only a read lock, that method can be called several times. But on this method, we want to have the default write lock, because therefore we're changing this array list. Otherwise we get into problems with this one here. And once we created that event, we will send the event using the output sync. And that's it. All we need for now. So what did we do here? We created, make this final. We created an event resource that listens on that path. That is a singleton because we store all the sessions here. And then we create a new broadcaster and registers new clients that come in. And also as a second feature, we take care of that last event ID header and say, okay, then we can resend the missing events that have been inserted in between, and take this number here, that is in this case both the index and +1, it's the ID, so event ID start with 1, and then we can send this to that particular event sync for that particular client. And once new events come in, we broadcast them to everybody and also track them so we can resend it later on for new clients.